Okay, so this is just graphing sine and cosine functions. And again, I'll give a little warning. This video assumes that you already have some experience graphing sine and cosine functions. So, um, if you don't know what these are, maybe go back and do a little more research before you just jump right into this, because this video is going to fly through it pretty fast. And so the first thing we're going to do here is I will go through some of the notes for this just to explain what things mean. And so this is just the generic form of the equation of a sine function. And so if you go through here, the x-axis in this case, because this is just y equals sine x. So this is the very simplest sine graph you can get. But this dotted line I'm drawing here is called the midline, and it's always represented by d. Notice d is 0 in our case, and so that should kind of make sense there. So d is 0, so the x-axis is our, and it's called our vertical shift, d is. So, I probably shouldn't have started there, but it kind of gives us, that's usually where you start every time, is you go to d, put a dotted line on the, along the, a horizontal line. And so d is always our vertical shift. Vertical shift. Okay, so up and down, how far is it going to go? All right, and I'm going to erase this y equals sine x. We know this, we've determined that effect, so we could use the space. And so now let's look at some terms here. So this distance from the midline to the crest, and this is midline to the trough, that is always a, or your amplitude. So a is amplitude, and it's always the same, the amplitude of the graph, of the wave, I should say. Okay, and then notice this graph starts here at 0, 0, goes up, crosses the x-axis or midline again there at about pi, and then comes back, and that's actually 2 pi, 6.28, and then it starts over again. And so from where it starts to where it starts over again, that is one cycle, and this is my period. This length here is my period. And notice that it occurs, 0 to 2 pi is a full circle. So we get one cycle, in this case, in 2 pi. And so our frequency, this variable b, that brings us to b. B is considered our frequency. And in terms of trig, frequency is, it tells you what the, how many times you get a cycle in 2 pi. So in this case, it's one time, because b was 1 in sine x. So b is frequency. And then our period, we know from, probably from your science class, that period is 1 over frequency. Well, we're going to go a little bit further, and we use 2 pi, since that's our cycle as a circle. And so it's 2 pi over b in terms of our formula up here. So if you want the period of this thing, or the length of one cycle, you have to take 2 pi divided by b. And then c is the last thing, and it's called phase shift. Phase shift. And phase shift determines how far left or right your graph is going to shift from 0, 0 here. And so to find phase shift, and I'm going to call it PS for phase shift, you would take negative c, oh my gosh, not negative 6, negative c divided by b. And again, that's coming straight from the graph. Here's c, and here's b. And you take this sign with it, this, whatever it is. So phase shift is negative c divided by b. So if you already kind of know how to do these, here is a great example of one. So I'm going to go through everything, pull up a graph, and we're just going to rough sketch these. I'll show you in Geogebra how you can quickly get the graphs. So a lot of these tasks with technology aren't really that important, but I think it's kind of nice to know where all these numbers come from and what they do to the graph. So like I say, the first thing I do is look at d, or this number, this constant added to the function, plus 4. That is my midline. So if this is our, x-axis and y-axis here, I'm going to go up 4 and draw a dotted line. And that is my midline. That's my sine graph is going to go above and below that d equals 4 line, or in our case y equals 4. But d is what I called it in the original. Okay, so that's the first thing I draw. Then amplitude, in this case, do this in red. Amplitude is 3. Your frequency, or b, is 2. Your period is 2 pi over 2, which would just be pi. And your phase shift, which I call PS, is negative, in our case, a negative pi over 2, which makes it positive, over 2. So I'll knock that out. 2 negatives make a positive. And pi over 2 divided by 2 is pi over 4. Because you flip and multiply, this would be 2 over 1, you flip and multiply, you get pi over 4. So we're going to shift this graph to the right, pi over 4. And I'm kind of getting too close to my work here, so I'm going to erase some of that. So that's all the information we need. So I look at the period. So we are going to cycle through this graph every time we hit pi. So that means it's going to go up, down, up by the time it gets to pi. So I don't want to go, I don't want to make my x scale. You wouldn't want to go by pi's. And so in this case, to give myself plenty of room, I'm going to go by quarter pi's. So this first one would be 1/4 pi, 2/4 pi, so this is pi over 2. This is pi. So we're already going to get a cycle by here. And there's 2 pi. And same going back. So there's, so there's negative pi over 2. There's negative pi. And there's negative 2 pi. And so we're ready to rock and roll here. So if we go, I always do my phase shift tells me how far over to go. We need to go in blue. And so we're going to go over pi over 4 to start with. So we're going to start right here instead of 0, 0. Okay? And we know the period is pi, so every 4 marks is pi in this thing. So 1, 2, 4. So right there, we're going to have a full cycle between those 2 dots. And so that means, since it's sine, it goes up, comes back down, and goes back up again. We know it's going to cross the x-axis here. And my maximum, since my amplitude is 3, my maximum is going to occur here, and my minimum is going to occur here. So here is what my graph should look like. Well, I didn't do so hot with this bottom one. And it's going to continue like that indefinitely. So put in my marks. It's going to go up to 3, through 0, down to negative, down 3, and then back up again. And it's just going to keep going like that. And I'll go backwards a little bit. So 4, it's going to be at 0 here. So it's going to go down to 3 there, back up to 3, down to 0. And like I say, it's going to keep going like that. Okay? And then if you look at, I just popped up the Geogebra and plugged it in. You can kind of see that here. Let me slide that over. Yeah, so there's my equation. and you can see that it matches, and kind of a nice way to check your work, or if you're actually doing these and have access to a computer, GeoGebra is a nice way to do this. So there's that one. And so here's another example. So go ahead and I would pause the video now and see if you can find everything. So I'm going to quickly go through it now because I'm running out of time. So my amplitude, in our case, is -2. My frequency is 1/5. And usually they'd put x over 5 there, but that was nice to you. My period is 2 pi over 1/5, which would be 10 pi. And my phase shift is negative pi over 1/5, which would be 5 pi's, as you flip and multiply, and is positive. And my vertical shift, up and down shift, is 3. So I'll call it VS is 3. All right. So I'll put a horizontal line at 3. I'll do it in green this time. So there's my midline. My scale is 10 pi, so this time I will go by ones. 1, 2, 3. So there's 10 pi, and then back 10 pi. Or maybe I could even go by 2's. So let's go by 2's. So there's 10 pi. And there's 20 pi. Okay, and then back. There's -10 pi. 2, 4, 6, 8. And there's -20 pi. So, going to be a stretched out graph. Definitely stretched out. And it's going to, now my phase shift is 5 pi, and this is a cosine graph, and it's -2 to boot. So we're going to go to 5 pi to the right. So 2, 4, so 5 pi, and then we're going to go down 2, and that's where we start. And I better do this in red, I suppose, today for this one. So there's my beginning part. So yeah, -2 down because it's negative. And so we're starting on a trough, and we're going to go up, down, up, down. So you can imagine this is going to go up through, and it's going to be at that same place 10 pi's away, because that's one period. So 2, 4, 6, 8, 10. So it's going to make a full cycle to that point. Well, since this is a cosine graph, and I'm starting at a trough, I know my max is going to be right in between those two, and it's going to be 2 above the midline. And my x-intercept is going to be right between those two. So I think it's right in here. So 1, 2.5. So 1 3/4. Yeah. So 1 3/4, about right there. And so here's what my cosine graph looks like. And again, you can go back through and do the rest, but I'm running out of time now. And I'll just show you quickly what it looks like in Geogebra. So let me pull up Geogebra. And so this is kind of cool. I went ahead and graphed it, and you can see that it's a really long graph. I'm going to change my x scale to fit in a full curve. And so there you can kind of see it. And I really had to stretch it out, or shrink it down. Here it's going by 5s, and you can look at each of those. You can look at how stretched out that is. 10 pi is 31. So it's every 31 about is going to be a full scale or full cycle. And so there you go. There's GeoGebra. There's sine and cosine graphing, And hopefully you can sketch these now. So best of luck. See you next time.